consider the equation x to the 4 equals 81. Can you solve this? Sure. What do you guys get? How many solutions are there?
2.
2.
But how many solutions should there be?
4.
Yeah, right. We know there should be 4. And obviously that's where your complex numbers comes in. 2 solutions could be real, and the other 2 are probably going to be imaginary. Right? So technically when you're saying, hey, there's only 2, which you were right, it's plus minus, what, 3? Yeah, that's fine. But technically if it says power of 4, there should have been 4 solutions. And those 4 solutions comes through the fact that 2 are going to be real and the other 2 are going to be actually imaginary numbers. Okay, terminology to get used to. The solutions of the equation are called the fourth roots of 81. Very important because that's how you're going to see it. Fourth roots of 81. What's the other words we've usually used for the solutions? What other words have we usually used for solutions of solving things? Yep, say it again.
Roots.
Roots. Another word?
Zeros.
Zeros. So, and now the one that you probably will see in extension 2 complex numbers is called fourth roots of 81. In other words, it means x to the 4 equals 81. And then solve. Okay, so be careful. The fourth roots of 81 does not mean the fourth root. Okay, so I'm just going to rub that out. It doesn't mean it's the fourth root. Okay, so don't go and count 1, 2, 3, 4, and that's the one. It's not like that. It's actually just trying to say find the 4 roots. So it's pretty much just trying to say solve. Okay, it's just the way we say it's a little bit different again. Okay, now very complex form of saying this, but important. Don't read into it too much. Don't worry, I'll simplify it. That letter is important, called phi. So it's just a circle with a line on top. Another Greek alphabet letter. Keep going. Phi, blah, 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 blah. You don't want to see the proof just yet. We want to get more to the formula, which we could just use and memorize. And that's more for yourself. If you want to read at your own time, you can. All right. When we're solving, so like when we're solving this, let's say, essentially we're going to solve for x, right? Before you guys wrote plus minus 3. Our x answers are now not just like that. They're going to be in r, cis, theta form. Sounds good? So they're all going to be in this form, mod arg form. What would r equal to? R is equal to a to the power of 1 over n. What does theta equal to? Theta equals to, let's write this a little bit cleaner, 2k pi plus phi all over n. So I want you to take a second there, understand what I'm saying. So that's your question. When we're solving, all of our solutions are going to look like this, where r is this, theta is this, and k starts from 0 and ends 1 less than the n you would have. So just absorb that, write it, tell me what, if you want me to explain what everything stands for when you're ready, and I'll explain it one by one.
I'm still confused on the was it phi?
Phi.
The symbol?
Yep.
Yeah. I don't understand.
What it represents.
Yeah.
Yep. So, well, there's a lot of things you wouldn't know what does A represent?
Yeah.
Yeah, what does A? So we're going to get to them one by one, but write them all down now. You ready? You ready, Shashanka, then?
Yeah.
R. This R for your solutions is equal to a to the power of 1 over n. N is the easy one. N is whatever this power is. So
Yeah.
if that was a 4, n is your power. If that was a 3, n is a 3. 2, 2, and so on. Easy?
Yep.
Which is technically what you would have done anyways, right? Think about, how did you guys get rid of the power of 4? How would you get rid of a power of 4? Wouldn't you fourth root it?
Yeah.
But then isn't the fourth root the same as 1 over 4 as a fraction?
Yeah.
Isn't it? I don't know. You tell
Yeah.
me. Maybe I'm wrong.
Yeah, it is. It is.
Yeah. So that's all you're doing technically, but you don't need to see it. I mean, whoops, that's square root 4. It's technically the same thing, but we can use that formula. It's probably a bit better. So n is easy. N is your power. A and phi. A and phi. As we can see here, A and phi. So this one here, this 81 must, and this is the bit, must be in mod arg form. So this 81 needs to be in mod arg form. When it's in mod arg form, can anyone tell me 81, for example, since we're using this example, 81, what would be its modulus? What's 81's modulus? Think, if you have to draw it up, think of what 81 is.
You know?
Say it again.
Oh, wait. No.
Modulus. What would be the distance of that 81?
81.
Still 81. Good job. What would be its argument if it's just there?
0.
0.
Yeah. So technically, the first step we're always going to do is write these in this form. Must be in mod arg form. When it is, just so we don't get confused between our different letters, I introduce this as A. So that's A, our new modulus. And this is going to be your phi. Just so you don't get it mixed up with your thetas. Make sense? So, Sashenka, this A and phi is your mod arg form for the original case, but then your solutions are always written as r cis theta. Does that make sense?
Yeah.
You'll see it in a question. So what the only reason why I've done it like this is so that you don't get your, if I said this was r cis theta up here, you're going to be like, but Sam, isn't that the same as this one? So I've just done different words so that it's not confusing.
Okay.
So that's A cis phi. And A represents the modulus of your original one. Phi represents your modulus of your original one. Whereas r cis theta is the solutions we want to get when when we're solving this. So r should be 81 to the power of 1 over 4. Theta would equal to 2k pi plus 0 all over 4. And so on. Is that clear?
Yeah.
Julia, what do you reckon? Clear?
Yeah.
So one more time. This is your A, cis phi. Only for the original case, because it must be in mod arg form. When we have that, then of course it's really easy. And the only other thing you need to know, K must start from 0, and then it'll stop at 1 less than the amount of n's you would have. Otherwise, you'll get too many solutions. And we'll see that, don't worry, when we start doing a question. Okay. Okay. Let's start with this. Solve the equation of Z4 equals to 1. You guys know 2 of them. What's the 2 answers anyways? Just out of curiosity,
Plus minus 1.
right? But now you're realizing no, there's actually 4. So let's do this. So z to the 4 equals to 1. What's step 1?
Mod arg form.
Yeah, so step 1 is we have to change this 1 to mod arg form, which is quite easy. It's actually 1 sys 0. Agreed?
Yeah.
Then, maybe for
Yeah.
now, since we're just starting off, why don't we label this? Label this as A, label this as phi. Then, what's our formula? Our formula is R equals A to the 1 over N, and theta equals 2k pi plus phi over N, for k equals 0, 1, 2, until I get smaller than 1 less than the n value I have. And you'll understand that in a second. Very easy. Okay, so in this case, let's use a different color. What does A equal to? 1. What does N equal to?
4.
So therefore, R equals 1. In this case now, 2k pi plus, what does phi equal to?
0.
Sorry. Give me 1 sec, guys. Hey, Dave. I'll call you back. Bye. 2k pi plus phi, which is, yeah, you said 0, over, and then again, what's n?
4.
4. And then k needs to equal to,
Wouldn't it
starting,
be 0?
say that again,
0.
0 all the way to,
3.
good job. Now let's just see why that makes sense. How many solutions will you get if I did all these amount of numbers? How many answers am I going to get?
4.
Yeah, isn't that the amount of answers I'm meant to get?
Yeah.
So if you went to k equals to 4 by accident, then you'll have 5 solutions, which is impossible. Makes sense? Yes.
E.
Yes. Done.
Yeah.
Okay. Then you're not done, right? Now we've got here. Then we know the answers are written in what form. So z equals
A.
r cis theta. Now the a is just for the beginning, right? So they're written like this. So what's your first r?
1.
1. Cis. What's your first k? What's your first theta? When you sub in 0 into, I mean, you can ignore this part. When you sub in 0 into here, what do you get? Then do it
0.
again. 1. Cis. You sub in 1, what do you get?
2
And
pi
again,
on 4. Oh, okay.
you get the idea?
Yeah.
4. And we're almost done. 6 pi on 4. And that's it. Those are your 4 answers. I know they look weird, but they're all right. Let's just simplify them. 1 cis 0. Oh, who writes 1? I just did that for so you guys know what I'm doing. Cis pi on 2, cis pi, and cis 3 pi on 2. What do we think? Did I make it easy? Like I said I would?
Yeah.
I hope. You know, that's a 5-mark question there. But you guys are probably thinking, oh, hang on, Sam. Some answers should have been ±1, right? Isn't that the conclusion we made at the beginning? If it's
Yeah.
±1, can we check some of these? Cis 0. Can you guys plug that into your calculator as cos 0 and sine 0? What do you get? Well, let's check what the actual Cartesian answers are. That's where you stop, but I just want to show you something else. So cos 0, sine 0, get me an answer. What do you end up getting?
1.
1?
Oh, cos 0 plus sine 0, right?
Yeah, because cos 0 is 1, I think,
Yes.
and then sine is 0. So that's just 1. Next one, cos 90.
That's 1
Should
again.
Cos 90 is 1? Nah,
Yes.
can't be.
Oh,
Cos
okay.
90? Oh, is it?
Cos 90 is 0.
Yeah, I thought so. Cos 90 is 0.
Yeah.
Oh, just cos 90, not cos plus
No, yeah,
cos
because you're
theta
doing
plus
this.
sine theta.
Right. Okay, hold on. When you're plugging this into your calculator, the reason why you can't do cos 90 plus sine 90
Oh, oopsie.
is what's in front of the sine?
An I.
I.
I. So when you're getting 1, you don't know which one's 1 now.
Oh,
So careful.
okay.
You just do it separately. So you just do cos 90, which is 0, sine 90, which is 1. So therefore your answer is I.
Oh.
That's how we change them from polar form into Cartesian form. So do the same thing again. Cos 180. I think I know the answers. It should be something like that. Just double check.
Is it required that we simplify all of this to,
No.
or do we just leave it in cis form?
Look. It's good to know both, right? The one that you'll 99% of the time you'll use is just the top form. But it's good to know that you can change some of them.
Okay.
Most questions you won't be able to change all of them, so there's no point of even doing it. Okay? But it's good to know it, because sometimes like cis 0, you might as well just write it as 1. But like the other ones, they might not work as nicely. Okay, good. Are we happy with that response so far? And then can you see you guys said you're going to get +1 and -1? There it is. But the other two responses you guys didn't think about, but you know it works. Because what's I to the power of 4 now? I to the power of 4. Hey, it works. Equals to 1. So you see how we get 4? We actually, finally, we get 4 solutions. Something you couldn't do before, but you actually can do now. Sounds good? Yes?
So does
Yeah.
Tell me.
the cos act as a coefficient to the I? Wait.
Does no, the cos acts as a coefficient of the real part. Because
Okay.
isn't cis 0 isn't cis theta cos theta plus I sine theta?
Yes.
So the cos would just be the coefficient of your real, and the sine would be the coefficient of your imaginary. Make sense?
Yeah.
So check them out again, whatever you want, and you tell. I'll wait for you until you say yes, then move on.
Okay. Yeah.
Happy?
Yeah.
All right, and then it says represent the roots on the Argand diagram. Now, there's my Argand diagram. I'm going to assume we didn't have the ones in blue. Cis0 is there. That's Z1, as in the first root. Cis90 is there. That's Z2, the second root. Cis_pi, that's Z3. Cis3 pi on 2, that's Z4. Can we see that that would be the solutions? And we know it's true now because we just worked them out. 1, there's 1. I minus 1 and minus I. Yes? Can you see how everything's linked together? It's all working out. Do we see that? Yes or no?
Oh, yes.
Yeah?
Yeah.
Yeah.
Cis0 hasn't gone up. Cis90, because we moved to the left. 90 degrees. There it is. Cis180. There it is. Cis270. There it is. And then, yeah, 1. I. There's no real. Minus 1. There's no imaginary. And then minus I going down. So all works out. Multiple ways you can get the same solutions. Good. Well done. Let's do that all again. Find the fifth root of 1 plus I, right? What does that mean? What does that mean as an equation?
One plus I fifth rooted. Oh, to the power of 5.
To the power 5.
Say that again. Yeah.
1 plus
Z.
I to the power of 5.
Z to the power of 5 equals 1 plus I.
Okay.
I know it's a funny one, isn't it?
Yeah.
You got to get used to that. Find the fifth root. So it doesn't mean like actually fifth rooted or find the fifth one. It's more, that means just Z to the 5 equals 1 plus I, and you got to find the 5 roots. Okay, what's step 1?
Put it in mod arg form.
What does root 2 represent? What letter have we used?
A.
And then this one?
Phi.
Phi.
Phi. Phi. It's fine. It's more represented. It's more pronounced phi. Look, and just to make something clear, maybe your teachers won't use A and phi, right? Doesn't mean you go and change your method for that. Just keep it uniform. Go over our work and you're done. Okay, continue. We know that we want to solve for Z. So Z equals to, R cis theta. But what does R equal to? And what does theta equal to?
R equals A to the power of 1 on N.
So therefore, A equals,
Square root 2 to the power of 1 on 5. Oh,
am I right like
Yeah.
that? Because we know we're going to use fractions anyways.
yeah.
Root, otherwise, you're going to write root 2 and 1 on 5. It just looks messy. Cool, beautiful. There's my R. So now I know what my modulus is for each one. I just need my different thetas. No, your modulus doesn't change, by the way, as you probably saw up here. It was all 1, 1, 1, 1, 1. The only thing that changed was theta, according to K. So go back. Theta equals 2K pi plus phi over N equals 2K pi plus pi on 4 on what number?
5.
For K equals 0 all the way to
4.
4. That will give you 5 values. Good stuff. And then, yeah, you pretty much just sub it in. So maybe we'll do our thetas slowly. I've run out of room as always. So I'm going to bring it up here. Okay, theta, let's say theta 1 The first one becomes when you sub in 0. Oh, sorry, sub in 0. What do we get? Can anyone see it quickly when you sub in 0?
Pi on 4 on 5.
Which becomes pi on
20.
Nice. That's the first one. Theta 2 becomes subbing in 1, so that's 2 pi plus pi on 4 on 5. Can anyone see that one quickly? 2 pi.
9
Ooh,
pi on 20.
9 pi on 20. If you can't do it that fast, maybe use your calculator. Just all you will do is forget the pi. So you just do 2 plus a quarter divided by 5. But otherwise, 2 times 4 is 8. Plus 1 is 9. 9 pi on 20. Good. Really, after you got the first two, you kind of know the pattern. So I'm guessing, would you know what the next one is without even substituting it in? See a pattern.
17.
Yeah.
17 pi on 20.
Yeah, and that's it. You just continue. And then check it if you want. If I subbed in 2, 2 times 2 is 4. 4 times 4 is 16, plus the 1 is 17. 17. Beautiful. All right, give me the next one.
8 times 4, 32, 33, 33 pi on 20.
Yeah, you're just adding 8 to 17. Oh, you did the last one. Sorry. Yeah.
Oh, did I do it?
That's okay. 25 pi on 20, and the last one should be. You happy with that?
Yep.
Girls? All good?
Yep.
Yeah.
Cool. And then you're not done because those are your thetas. So what's your actual Z? Which is going to be annoying to write. But what's your Z's now?
R says pi
Yeah.
on 20.
Like
R
that.
says
2,
9 on 20.
1 over 10. Cs.
Oh,
pi
my
on
bad.
20. Next one. 2, 1 over 10. Cs. You get the idea. Do I need to continue? I think in your books, you should be able to just write them for the different angles. And those are your 5 solutions. Well done. Good stuff, good stuff. Just let me know when you're done, please.
Yep.
Yep. Okay. Can we get the marks that I need for this? Step 1, modulus, argument. Step 2, obviously memorize the formulas. Then plug it all in, finish it off. Really, nothing too crazy. Same, easy next week. Let's add the syllabus, I should take that out. Easy. Okay, that's the one. Find the 3 cube roots of -1. So what are you actually finding? Z.
Cubed equals -1.
Yep. All I'm going to say is everything should be the same, or everything is the same. Just tell me what you get when you do your mod arg for -1. I'll tell you if you're right or wrong. So do everything else otherwise, but just before you get everything else wrong, just tell me what your mod arg is for -1, and then go ahead, guys, try it out.
I just got -1. This is 0.
-1 says 0 is incorrect. Firstly,
1 says 0. So
yeah, I was going to
this
say,
is
firstly,
0.
what do you know about modulus? What's
It's
the
ju-
definition? What's the definition? Starts, yeah, go ahead.
The distance
Right?
from the point to the origin.
So not allowed. You can't say it's negative. So then you're saying it's 1, which I agree with. And then did you say cis 0?
Yeah.
Do you know it cannot be? Think of the location of this. Remember, always draw.
180.
It's good. Exactly. So when you said 1 cis 0, that's there. -1 is all the way to the left side. So that can't be cis 0 still. So be careful.
Yeah.
Now you guys can do it. Go finish it off. Just be careful, but can't make those mistakes. That's an easy 1 mark. That's got nothing to do with solving. It's just changing mod arg form. And the best thing is just to draw it up always. When you have an answer, let me know. I pretty much know what the answer should be.
I'm pretty sure I got the answers.
Yeah, try. Go ahead. Z equals
Cis pi on 3.
cis pi on 3.
And then cis pi.
Cis pi.
And then cis 5 pi over 3.
Cis 5 pi on 3.
Yeah, I got that as well.
Yeah, looks perfect. Yep. And then, just out of curiosity, if you had to draw this on an Argand diagram, right, without doing, whatever we had to do before, which was changing this to Cartesian, cis, what angle is this? What
60
angle is
degrees.
this?
180.
60 degrees. The next one is?
180.
And the next one is?
5 times 180 divided by 300.
300. What's your modulus for each one?
1.
1. That means technically, something I didn't say before, if your modulus is always 1, think about it. Isn't it just on a circle? Firstly, must it not lie on a circle? True or false?
True.
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 Right? It has to lie. It has to lie on a circle like that because its modulus is 1. Right? So you're saying the distance is 1. I haven't shown you the location yet, but if the distance is 1, it would lie on a circle. So let's see exactly where this is. So that's not part of the answer. It's just something that it's good to know. If you draw it, it's not technically wrong as long as you label them maybe Z1, Z2, Z3. Look, Z1 is there. Right? Isn't it? 1, that's your distance of 1 and gone up 60 degrees. Z2 is specifically right there. And then Z3, 300 is right there. Anyone see anything special with the way
It's-
I've drawn it? Say it again.
It's going like in a circle. So
It is in
Like-
a circle.
It's
The
a YOLO
angles.
symbol.
What else? Yep. Sorry, Shashenko. Rav, what were you going to say?
Oh, don't worry.
No, Shashenko, continue.
yeah, I think
As
it's
I
just
said,
the obvious.
it's what you see. So you see that it's definitely on the circle. I agree with
It's a
that.
third, like it's in thirds.
Ooh, is it? Let's see, 60. That's 120. That's yeah, you're actually right. I didn't even realize that myself. Never thought of it like that, I guess. It is in thirds. That is 120. That's 120. This one, you're actually right. Hey, look, she discovered something I never thought about. But she's right. Yeah, that's 120, 120, 120. So it did split it up in 3, actually. Nice. What about this guy here? You know, I didn't draw it like this for a reason. Right? It's exactly as Shashenko said, it is in thirds, but it's exactly in line with this. Because both of these are 60 degrees there, technically, aren't they? Because if that's 300, you know that's 30 degrees there, which is 30 degrees there. So you've got to be aware of that they fall in line like that. It's good to know that these particular properties. All good?
Yeah.
Moving down. Then locus. Okay, so we're technically done with solving, but no, they get very hard.